All right, so when you're looking at this, it's very much a conceptual question. And I think maybe the best way to do something like this, you could try and reason through, but maybe one of the best things to do is just pick a few numbers to use. Oops, why did I pick those? I don't know what I was. That's what happens when I talk and write at the same time. I just meant 1, 2, 3, and 4. All right, and the reason I picked this is if m is an odd integer. So let's say that m is 1, which means that these three could be the other one, n. So if I add 1 plus 2, I get 3. Okay, that's odd. If I add 1 plus 3, I get 4. Well, that's even. So it turns out just having m as an odd integer doesn't work. Now, if I said this was n and all these were m, I could do the same thing. I get the same result, right? So 1 plus 3, if n is odd and m is odd, it looks like I get an even integer as a result. So let me get rid of all that. These two are not correct. So what if they're both odd? I'm just going to pick 1 plus 3. So if m and n are both odd, 1 plus 3 equals 4. Well, I get an even integer. So it turns out that's not true. If they're both even, I'll do 2 plus 4. And I get 6. That's also even. So none of these always give me odd integers. I already found cases where that's not true for the first 4 examples. And finally, it says m is an odd integer, n is an even integer. So if it's m plus n and m is odd, then m could be 1 or 3. And n could be 2 or 4, plus 2, plus 4, plus 2, plus 4. Okay, so basically those are all the combinations of evens and odds that we have there. So that gives me 3, 5, 5, and 7. And look at that, they're all odd. Now this is not on its own a definitive proof, but it does show me that this is the only one that's likely true, and we could do even more to show that. Okay, so there's your answer to the bell work today. And what we're going to be doing is just kind of using today as a practice day, so I don't need to tell you too much, but we're going to also practice some equations. And we have the time for it. We're only going to look at 3 today. I'm just going to run through the first one, so I'm going to have you guys do 2 of them. But what we've got is, it's a pretty basic equation, but what we're using in this case is the distributive property. Now, we could theoretically do this without the distributive property, and maybe some of you are looking at it and thinking, you know, you have a different way of solving it. But I want you guys to practice with the distributive property. So that means when you have terms inside of a parentheses with a number outside, a coefficient you're multiplying by, then we need to distribute that to everything inside the parentheses. This is not new. You know about this rule already. So if I multiply that out, 6 times 2y is going to be 12y. 6 times negative 2 gives me minus 12, and then equals 36. Nothing changes on the right. And now it's a pretty basic equation. I can add 12 to both sides. And 12y equals 48. Divide by 12. This is, you know, individually, you might like to use a calculator for this. But if you already know 48 divided by 12, then you can just figure out that y equals 4. I know I kind of went through some of those steps a little fast, and you might take a little longer to get it done. Timing isn't the issue. It's just making sure you know how to do it. So that's the basic idea. And you're going to have problems like this as part of your homework tonight. They're going to be randomly generated. So, but they're all going to look essentially the same. So what I want you guys to do is look at this one and see if you can come up with an answer. I'm going to give you a 1-minute timer, and then of course I'll hopefully someone will be comfortable putting their answer on the screen. So let me get the timer going. You can get started right now. Okay, that was great work right there. You can see the entire problem has been worked through, and excellent job on that. And so if you were following along doing that at home as well, that's great. So, hey, I don't even need to talk about it anymore. You can see the entire work right there. Well done. All right, so for the next one, I want, let's keep the screen empty and just work on this one at home on a scratch piece of paper. And in about 1 minute, I will ask for answers. Okay. Okay, so we have an answer on screen. It says x equals 3. Did anyone get something the same or different? Got x equals 1, x equals 3. And there we go. A couple of votes, I guess, if you think of it that way. A couple of votes for x equals 1. And maybe some other people got answers as well. Let's just run through it real quick. So if I distribute out this, I'm just going to do it off to the side. I get, I get 10 times x plus 10 equals 20. And now I can subtract 10 from both sides. That cancels out, and I'm left with 10x equals, if I can think, that's 10. All right. So maybe what happened for the 3 was that this was added, 10 was added accidentally. Not a big deal. Now we can divide by 10 on both sides, and we can see x equals 1. Okay, so no, we don't need to do any more practice problems of this. You're going to have this as part of your homework tonight. So I just wanted to run through, remind everyone that there's going to be a mix of just kind of basic, and I don't want to say basic like easy, but basic like foundational math skills that it's just really good to get that practice in. So when I give you homework that has certain skills in it, I'll just randomly throw in stuff like this too, because it's good for you to practice. All right. So let's go ahead and do this. Raise your hand if you're here. So I just wanted to remind you of these rules. We went through all of them over the last few days, and these are going to be important for you to not memorize. You will always have these as a reference that you can just look at over and over again, but it is important that you know how to pick the correct coordinate rule to use. And just as a quick thing, not that you need to know, but the reasons I gave them these letters, which I don't have to give them these letters, I could call them just A, B, C, D, E, F, and whatever. But of course, I call this coordinate rule Y because we're reflecting over the Y-axis, X because we're reflecting over X, P because this is a positive slope right here, N for a negative slope, L because if we're looking up like at the top of a circle, we're going to the left to go counterclockwise. If you're looking at like the 12 o'clock on a clock, you're going to the right when it's clockwise. And then C for kind of like a complete turn to the other side. I don't know, I just had to pick some letter. And so that was it. And then T, of course, is translation. That one makes a lot of sense. So the letters themselves don't make a lot of sense, or not, sorry, they don't make a difference. Hopefully they make sense. But if you don't know what those letters mean, it's not a big deal. The coordinate rules are going to be important. Okay, so there is homework on Delta Math. I just want to show you real quick because some of this, it's important to know what you don't need to do. All right, so this is going to be a mix of all different types of problems. You're not going to have a graph for this, but you will have a coordinate given and what your transformation is. So it's saying you're going to have a rotation of 180 degrees counterclockwise. So what I want to do, and I know it's not on the screen anymore, but I want to think about what is my rule for a 180 degree rotation. Clockwise or counterclockwise doesn't matter here. 180 degrees, my rule is this one. And what you would do is you would have that reference sheet, you would look at it, you would copy this down somewhere, and then you'd be able to say, okay, so I've got XY getting plugged in. So the C of -4, 7 is going to be, well, if all I'm doing is changing the sign of them, that's going to be 4, -7 when I'm done. And we can make sure we did that right. 4, -7, submit our answer. And sure enough, we did it right. If you make a mistake, it's going to give you some hints. So maybe you picked the wrong coordinate rule. Maybe it's just like a small mistake that you beat yourself up over. But whatever the case, you will be able to work your way through that. So let me pull up another problem. That's just another rotation. Here we go, translation. Translations are a little bit weird. Because my translation rule just says, I take this X and Y and I need to change this rule depending. So I'm going to take the X coordinate, since I'm going left 3, that's the same as going negative direction in the X. So I'm going to go X minus 3. Up 4 means I'm going to take my Y and add 4 to it. So that's my translation coordinate rule. And you might or might not choose to write down the rule exactly that way. But I will say on your test, you are going to be required to show all your work. And I need to see something. So I don't just want to see your coordinates put in right here. I want you to do something more to show me the work you're doing. Anyway, so now if I'm doing this translation coordinate rule for 8, negative 4, then that's going to be 8 minus 3 and negative 4 plus 4, which gives me 5, 0. So let's see if that's right. 5, 0. And we did it. Again, you can see the coordinate rule, they show it there. All right, maybe if we can find a reflection. Okay, this is one I wanted to look at too. There are going to be some of these that say dilation. And we have not talked about dilations. We're going to talk about those later. Now, I can't figure out how to not include dilations in this. So anytime you see dilation, you can just really quickly put 0, 0, submit the answer. It's not right, but that's okay. I don't really care about that. You don't get penalized for wrong answers on this. So you can just go through it and get a new problem. So I'm going to see if I can pull up a reflection. For some reason, it doesn't want to give me a reflection. Wow, this is crazy. There we go, finally. Gosh, that took longer than I expected. So reflecting over the y-axis means I'm using this coordinate rule. And I don't know it ahead of time, I just have to figure out the correct coordinate rule every new problem I get. So reflecting over the y is going to be negative x, y. So the y value stays the same, but the x value does not. I'm going to change the sign. So y of 3, negative 4 is going to give me negative 3, negative 4. Remember that the y value that we start with doesn't change. So if it's negative 4 to begin with, it stays negative 4. But the positive 3 is going to change sign to negative 3. So let's plug that in. Negative 3, negative 4. And we got it right. Again, it gives you that in case you made a mistake, if you picked the wrong coordinate rule. Okay, it's nothing new today. It's just going to, you're going to have an opportunity to get a lot of practice using these and picking out the correct rule. So if you have any questions, you can feel free to stick around, ask those questions. But if you are feeling like you understand everything, you're good to go. Have a wonderful weekend, and I will see you on Tuesday, 3-day weekend. Have a great weekend.